Hi, I'm Narid from Pure Magic or Electrical Magic, as you know. So now I'm going to show you how we can make this PCB better. First of all, if we hit 3 on our keyboard, we can go to 3D view, and with 2 we can go back to the 2D view, as you know, right? So let's just start from here, from the power, right? There is 24 volt, 0 volt, and earth that is coming from here, and there is a ring around it for the earth, right? So first thing that I notice here is that there is a lot of data space here. You can see there is a lot of data space that we can easily make this PCB smaller if you want, of course. Maybe who that give you this project to do it for them told you that the size of this PCB we want it to be like this, right? But if you don't have any limitation on the size of the PCB, you don't need these data spaces in here, okay? And after that, first thing that I noticed here, I think because of these overlays, you put this capacitor at the left a little bit, right? So you did it to make it more beautiful, right? But in PCB, beautiful is not that much important. What is important is the tracks, the placement. The priority is with placement, and after all the placement and tracking is done, after that you should add these guides, right? These all are just guides, right? So first thing that I would do, I will change the position of this capacitor. Let me again turn this all on. Put this capacitor, select both of these, hit A on your keyboard and align horizontal center with this, right? So it will be like this. Let me use Control W to change it like this and change this like this. We want to delete this stuff here because we don't need it anymore. So like this, right? We don't need this as well. We don't need this. With backspace, I can delete these at the middle. Maybe this way is much better, right? This will be at the middle of this. Or just make it center this path with this, okay? This guidance, this text is the last thing that you want to do. Of course, it is important, but the placement and routing is much more important. So next thing that I would do, I will change the font. Of course, it is okay right now, and for some manufacturer, this type of font is better, but I always make it bold. Just select it and click on bold, and it will be bold, and it is more readable, right? But for some manufacturer it is better to use not bold. You can change all of these designator to bold very fast. Just right click on one of them, find similar, and the bold is off. So we should say whatever text that is not bold. So hit OK, and it will select all the text that are not bold. Okay, so now we can change it to bold. Now you can see all the text in here are bold. You can see we did it fast, and there are some guidance and we ruined this one, so we shouldn't select this one. We should unselect these ones and just change the boldness of these text, right? Next thing that I noticed is about the MCU and the bypass capacitor on MCU. Let's just find out. If we go to tools, to cross probe, and click on this MCU, it will open it and select it in here for us, right? This is our MCU, and right now I can't see any bypass cap in here but these ones, right? So these ones are the bypass caps. The placement of these bypass caps, let's just select them and see if it's where it's placed, and all of them is placed here, right? So you can see these bypass caps is close to these pins, the VCC pin, and that's a good thing to do. It should be like this, right? It should be as close as possible. The next thing that I want to talk about is these vias. Why you make it this big? I see there is some via in here that are smaller. You know that PWM doesn't need a lot of current, right? So you don't need this big via, so you can make this smaller, and maybe it is better to create this via out here. So don't create via below the MCU if you can, but if you can't do it and you don't have a space, you can create that. But always it is a better practice to create via outside of the MCU, not in bottom of that, right? Not below that. And again, it's a good idea to not track your nets below the MCU. But if you can't do it, it's okay. There's nothing wrong with that. Always the documentation suggests that don't do this kind of stuff and try to route it not under our MCU. But if you can't do it like that, this will be okay for this case. It doesn't matter that much. Again, about test point, we did talk about test point in last video, and again, let's just again show you this test point, for example, that is 3.3. If you click on it, you can see it's just saying TP30, and if you go to property, you can just say to show me comments by clicking in here, and don't show me the designator, right? So no, the comment is in here, and for selecting that, it is in top overlay. So select the layer and put it, for example, here, and you can double click on it and change it to invert and give it some border like 10 mil, okay? And know whoever that see this know that this test point is 3.3 volt, okay? We did talk about it in the last video, but I wanted to mention it here as well. Next thing that I want to talk about is about this ferret. Okay, we call it ferret. I don't know what you call it, but you can see if we again go to tools, go to cross probe and click in here, it will open up the power section and show us this in here. So what this ferret do, it will separate the left side from the right side, and it will denoise something. It will filter some noise, right? So it is important that this part on the left and this part on the right have some space, right? So if you go to a PCB, you can see in here it's too much close, and it don't need to be this close to this pad in here, because we don't want any noise from this side to go to this side, right? So I think the better way to do it will be something like this. Okay, as much space as you can for these filters to work correctly. And for this, again, if you want to do it, you can do it like this, right? And like this. Or you can do it like this, okay? I think this way is better. And because you have a lot of space, you could just do something like this. So again, in PCB, like we can say that this side and this side, in PCB, we could just say that as well. So you put that in here and change the position of this, because this one is more important, right? So next thing that I want to talk about is this svcc, okay? For selecting this track, hit S on your keyboard, and after that N to select the net. And now if we unzoom, you can see where these svcc go, right? It will go here to the sensors, right? First of all, you should calculate this sensor how much current they want, okay? So after you calculate that with Saturn PCB that I showed you, with the software that is called Saturn PCB, or some calculator that is free online, you can calculate what is the track size for that current that you need, right? So in here, because you have a lot of space, I think you should make this SVCC a little bit thicker, right? But I think it's okay, because of course you calculate the current that you need and you choose this track size that is, let me see, 30 mil. I think 30 mil is more than enough, right? Everything cool with that? Let's just go to the next. You see in here, for checking your PCB, I think it's always better to go to single layer with Shift S, okay? Now you can see, I can see everything clearly, right? So for example, if I go to bottom layer, and in here, what you can see in here, the first thing that I see in here in single layer that is easy to find out is this dead copper. It's not connecting to anywhere. So why it should be there? And second thing that I see in here, you connect this to here, okay? And it's for shift register. It doesn't matter that much. It don't need to draw any current. But you see, when you have a space, make your track as big as possible, right? So if you make this a little bigger, it will be safer, right? So like 20 mil. Why you shouldn't do this like this, right? I think you should do it like this. And for removing this dead copper, because it won't do nothing, right? Go to tools, go to polygon, polygon manager. For example, this bottom layer, that is this one, right? And in here, in option in here, just check this remove dead copper, okay? Hit OK. And now again, go to tools, polygon. After you check this remove dead copper, click on report, modify polygon, hit yes, hit OK. And now you can see these ones is not dead copper anymore. It's connected to the ground, right? You can see it's connected to the ground. And this is a little bit bigger now. Everything cool now? Let's just move on. Next thing that I'm gonna talk about is these tracks. If you click on it and go to property, you can see it's just 10 mil, but we have a lot of space in here. Why we shouldn't add more width to it, right? Why I'm saying that it should be a little bit bigger. Of course, you did the teardrop in here, but if you make this track bigger, you can always desolder this connector, and you don't need to worry about peeling off that copper in here. So make it a little bit bigger, this track a little bit bigger, so if you want to desolder something, it won't ruin your PCB. So you can see we have a lot of space, and I think we should make it a little bit bigger for this track. Next thing that I'm gonna talk about, let's just again hit Shift S to see everything, and you can see there are some test points in here. If we go to 3D view and we go at the bottom, hit 0 to see it, and you can see there are some test point in here that is in bottom of our PCB. You can do it, it's okay, but I think the better way to do it is always to add your test point at the top and use test pin. Test pin is very much better to use with probe because it will stuck in there and it will don't go off and short something and ruin our PCB, right? So what I think is that you could just put this test point, for example, here at the right? You had a lot of space. You could just use all of this space. At the bottom, it's hard. It's hard. You should flip your PCB when it's on and test. It's hard. It's hard. Believe me, it's hard. So it's better to use test pin, not test pad, for test point and put it on the top layer. It's very much important. I think you should do that. It's very much important. Next thing about these relays, how much current this relay wanna provide, okay, and how much voltage. Because you have a lot of space in here, maybe for the output of the relay, you should make these tracks a little bit bigger. At some point, we don't need to make it bigger because we need some resistor in there as a snubber effect, right? But if you are not sure how much current these relays should provide, just make it as big as you can, right? The tracks is important. So right now, if you go to properties, 30 mil, it's good. I think it's provide the current that you need. But again, read the document and ask the employer to see how much current that they wanna draw from these relays, right? And design accordingly. I did talk about all of this calculation in such a PCB in our class, and I know you know how it works. Next thing that I want to talk about is this interface in here. First of all, you don't need to do this kind of stuff to length match this with this, okay? But if you length match it, it will be much professional. It will be better when somebody see it, they know that you care a lot about your PCB, right? If you length match it, it will be great, okay? And next, just give it some space. You have a lot of space. You don't need to make it this much close together, right? This much I think is enough. When you have a space, just use those space. Next thing that I want to talk about is if you go here, you can see this status LED. It's not as important as this PWM, right? This is PWM, this is clock, this is PWM, this is status LED, this is sensor. So the sensor pin and the PWM is much important than a status LED. So it's better to put your status LED wherever you want. And first, plan your tracks first, because the tracks for PWM and sensors has bigger priority than a status LED, okay? Just change the position of this status LED so you don't want to need to do this PWM go through an LED and this sensor power enable and this clock go near this status LED. You don't need that. You have a lot of space, so put this somewhere else and route your tracks again. And that was it for this PCB. And at the end, I want to say that this is a good PCB. It will work like this, but you always can make it a lot better. And again, this is good, this is beautiful, and I'm so proud of you. And it's an honor to have you here. Believe me, you're so good. Thank you so much for watching. Bye.